Hello everyone, and let's quickly recap what we have done. We have already done the constraint motion where we have seen the string, pulley and block, and what you have seen is string constraint. We have already done these given problem. Now today our task should be how we approach to the next type, and today we will going to see few more methods and shortcut as well. So I thought this much part we have already done. Now let's quickly begin next method. Next method is called as point method. Now in case of point method, we can say we will once again try these questions that we have already done with the help of point method. Now let me quickly tell you, if we are talking about pulley, so pulley, let's take these two section B and A, and let's take pulley is moving with velocity Vp. Fine. So we will going to mark some point on it. Let's say the point is, this is attached to A, this is attached to pulley, this is attached to pulley, and this is attached to B. Fine. So these are the point, and let's say कि once this static, both will moving upward along with the pulley. So this is velocity of Vb, velocity of Va. So once you are looking for B, so B is approaching towards the pulley. Fine. This point is approaching towards the pulley. Point B, we can say point B is approaching towards the pulley. So this length will start reducing itself. Since this length is reducing, that's why we can put the velocity of Va as minus Va. Always remember, once this point is reducing, we'll put with minus A. What about this particular point? This is the point that is the part of pulley, and since pulley is moving with Vp, hence we have expressed as Vp. This point is also a part of pulley, so we can say plus Vp since it is moving along with pulley. And this point, next point, it is moving with Vb. Since this length is decreasing, hence I can put minus Vb, and all must be equal to 0. So what we can see, Vp is equal to Va plus Vb divided by 2. Same formula we have discovered as we have discovered earlier. Fine. So let's see few question that is based on it. Question number 1. This is the pulley system, and these problems seems to be very important, and this point method will really give you a simpler edge, and it will solve your problem very quickly. So step number 1, you're supposed to mark point quickly. So how many points were there? 1, 2, let's say this is A, and it is moving with 2 meter per second. Then pulley, then this is B, block moving with velocity 6 meter per second. So these 2 points must be moving downward. This is part of pulley, this is C, and Vc we supposed to calculate. Now you have to express the velocity of each points. So let's start from this point A. So here we can say, since A is reducing, hence we can put -2 plus these 2 points is 0 plus 0, because here the velocity will be 0 because pulley is not moving. Then we are approaching these 2 points A and actually B. So both point will be moving with velocity 6 and 6. Then once again these two will be 0 and 0, and once it will reach to the point next, let's say VC, we are not sure about VC is moving downward or upward, we can say plus VC equal to 0. So after calculating we can get VC is equal to 10, that is moving upward direction. So I thought this method is really very helpful, and let's try one more question so it will give you the better clarity. Question number 2. So question number 2 was, this is the problem, it was asked already in your paper. Some pulley system over there, and this is connected like this. This is B and this is A. Let's say this is moving with 10 meter per second. This is velocity of B. Let's quickly mark all the points first. So 1, 2, 3, 4, 5 and 6. Now here we can say once moving 10 meter, what will happen to the VB? So this point is moving with 10. Then what about this point? This point is moving with velocity plus or minus VB, because this is decreasing, this length is decreasing, and here as well that is decreasing, minus B. And what about this particular point? These are moving with 10 plus 10, fine. And the last point, since it is static, so we can say plus 0 equal to 0. Clear? So after solving we can get VB is equal to 30 divided by 2, that is 15 meter per second. What we have understood, this is increasing, these two increasing, these two decreasing, and this is 0. So let's quickly attempt one more question that is based on it. Question number 3, and this is homework for you if you can manage this problem. Fine, these two connect with some A, B, fine. So this is moving with 4 meter per second. This is point, only mark all the points quickly. So these are the point. Now let's 4 is increasing, hence 4. Then next 2 it will be 0, and this one is 0. The next 2 it will increasing, hence VB plus VB, these two VB. Then again these two 0, 0, and next 2 VB and VB, and last point is fixed, 0 equal to 0. So by this calculation we can get the value of VB very easily. So point method seems to be useful, because earlier method that I told you about, that VP is equal to VA plus VB by 2, that may be not very helpful as compared to this point method. Fine. So let's quickly do one more that is based on it. This was the problem. Once again, it was asked in your paper. Some pulley were there and some block. So here we can say the block and wedge. This is an interesting problem as well, because earlier problem what we have seen, the wedge, the block is supposed to be moving downward with velocity v. At the same time, this wedge is moving with velocity 10 towards it. So this is moving with respect to wedge and wedge itself moving. So this look like bit tricky, but we can solve with the help of point method once again. Let's mark point quickly first. So point would be 1, 2, 3 and 4. These are the point. Fine. So 1, 2, 3 and 4. Now do one thing, like this is a relative motion. So let's make the relative motion away from all the discussion. So let's start, settle down on the wedge itself. Once you are looking everything with the wedge frame, we can say wedge velocity should be 0. So what I supposed to do with respect to wedge, what about the motion of this point? So here we can say opposite velocity we supposed to add everywhere. So here we can say this will moving with respect to wedge. Point 1 moving with velocity 10 meter per second, and since it is in moving towards the pulley, hence it will be expressed with minus 10. This is point 1 plus, what about point 2? Since point 2 is a part of pulley and pulley is a part of wedge, so it would be 0 and 0, because with respect to wedge the point 2 and point 3 is relatively at rest. And last point, let's take moving velocity v should be equal to 0. So by this way we can get velocity of v, that is with respect to wedge, it will be 10 meter per second. So this is important. Once you will doing the same problem with respect to ground frame, it will be a bit tricky, but with respect to wedge frame it look like very easy. So these are the problem that we have done, and those are problem that is based on wedge situation. Now let's quickly do one more, and this will be the last problem I thought. Once again, this is a important question. Let's take some block is there. Fine. And this is connecting like this. Once the wedge is moving downward direction, let's take v. So what will happen? Let's quickly mark the point first. So with respect to wedge, wedge is moving with 10 meter per second. So if we are discussing with respect to wedge frame, with respect to wedge frame, let's quickly mark the point first. 1, these are the point locations, correct? These are the point location. So With respect to wedge, we can say the point is moving with velocity 10 meter per second. So we can say this point, this is the point that is moving with velocity 10 meter per second towards, let's say 1, 2, 3, 4, 5, 6, 7, 8. So point 1 is moving with, since it is decreasing, fine, and this is a part of pulley, so 2 would be 0, 3 would be 0, and V, of course, 0.4 V. What about 0.5? 0.5 is a part of which it will be 0, fine. What about the 0.6? Since 0.6 and these are the connected portion of it, and these two it is not moving, we can say this 6 point, we can say 6 point, it is moving towards the wedge. So 0.5 will be 0.6, it would be minus 10 because it's moving towards it. 0.7 and 8, it is not moving towards it, it will be just parallel to each other. We can say it will be 0 and 0 equal to 0. So by this way we can get the value of V. The point to be noted, 0.6 and 7, because it is moving towards 0.8 and it is not moving towards it, hence it will be remain 0 because it is moving vertical direction, not towards it, and these 2 point is moving towards, and this is a part of the wedge. I thought every point is clear to everyone. So by this way we can get value 20 meter per second. Now one constraint problem it is there, we'll surely see, or let's finish it up quickly. Last it is called as wedge constraint. Now as far as the wedge constraint it is concerned, let's take this is the portion. Now this is in between of the some constraint, and once the block is moving with velocity v1, so it will push, and by this way this block is moving with velocity v2, let's say v1 and v2. Now always remember, in this section we can draw and only draw the perpendicular of it, and here we can say this is moving with velocity v2, and the first section is moving with velocity v1, and it is making angle some theta, so this will be theta, and this will be 90 minus theta. Now perpendicular direction, always remember wedge constraint, the perpendicular direction velocity is not changing, so we can make it resolve along the perpendicular direction. So this velocity will be v1 cos theta, accordingly this velocity will be v2 cos 90 minus theta. So by this way we can say v1 cos theta, velocity is not changing, so it will be equal to cos 90 minus theta. So by this equation we can say v1 cos theta should be equal to v2 sin theta. So this is the wedge constraint. Let me give you the last problem for your homework. This is the situation. It is moving downward with velocity 10 meter per second. You have to calculate the velocity v. Once again, you have to use the same constraint, make it resolve perpendicular direction, like this is the perpendicular direction of it, and it is moving with 10 meter per second, and here it is moving with an angle they have given as 37. So once angle it is given, you can better to calculate these two angles and make it resolve along the given direction, and these two would be equal to each other. So by this way you can get the final relation between 10 and v. Always remember this wedge situation. Finally resolve the velocity along the direction perpendicular to the contact surface. As you have done in the string case, every velocity is resolved. Now as you have seen, every velocity is resolved in the direction of string. Very similar you can do, all the velocity is resolved in the direction perpendicular to the normal direction. So by this way we can say we have completed constraint equation. So all the best for